VLSos here. This is a video lesson on inequalities solving. For example, 3y plus 2 is greater than and equal to 11. This is an inequality. There's a variable, but it's not solved for. It's not alone and positive on one side yet. How do we solve for y? How do we get it by itself? Well, we know how to solve equations, so we're going to treat this inequality as an equation. With one extra step. And if we recall, we solve equations by undoing operations with their inverses and remembering that what we decide to do to one side, we must do to the other. And through a process of undoing all the things that are being done to our variable, we'll eventually get the variable by itself. But there's one extra step or consideration when solving inequalities, and it's this. When multiplying, or dividing by a negative number, you must switch direction of the inequality symbol. This might make sense if you think of multiplying and dividing by a negative, which means that you're taking the negative of something. You're taking the opposite sign. So if you turn a number into its opposite sign, you also have to turn the symbol in the opposite direction. So we'll get practice with this. We're going to solve this inequality for y. We need to undo multiplication by 3, and we need to undo this addition of 2. I'm going to undo the addition of 2. Subtraction is the inverse of adding, so I'm going to choose to subtract 2. And they will cancel out. But what I do to one side, I must do to the other, so I need to subtract 2 from the other side as well. After subtracting 2 on the left, the 3y is still there. 11 minus 2 on the right, make 9. And the symbol in between is still greater than or equal to. I have one more step to get y by itself. I need to undo multiplying by 3. The inverse of multiplication is division, so I'm going to choose to divide by 3. What I do to one side, I must do to the other. Multiplying by 3 and dividing by 3 at the same time cancel out, leaving y by itself. On the right side, 9 divided by 3 is 3. And the symbol in between remains greater than or equal to. Now, nowhere in this process did I multiply or divide by a negative. I subtracted, but that's not the same thing as multiplying or dividing. And I divided, but when I did, I divided by a positive number, so I didn't have to switch the sign. My final answer, y is solved for. Y is greater than and equal to 3. Let's do another example. Negative 2 times x plus 4 is less than 10. This is an inequality. It's one variable. I need to solve for that variable. I'm adding 4 to it, and I'm multiplying the x plus 4 by negative 2. There are a few choices to make. I could undo this multiplying by negative 2 first, or I could distribute first. I'm going to choose to distribute. This negative 2 is going to multiply the x and the 4. When I do, negative 2 times x is negative 2x. Negative 2 times positive 4 is negative 8. And this is still less than 10. To get x by itself now, I need to undo subtraction by 8 and multiplication by negative 2. I'm going to undo the subtraction of 8 by doing its inverse, add 8 to both sides. These will cancel out, leaving the negative 2x. 10 and 8 make 18. The symbol in between is still less than because adding a positive number doesn't change the sign. To get x by itself, I need to do the inverse of multiplying by negative 2. I'm going to divide by negative 2. What I do to one side, I must do to the other. Multiplying by negative 2 and dividing by negative 2 cancel out, leaving x. 18 divided by 2 is 9, so 18 divided by negative 2 is negative 9. And the symbol in between now has to switch direction, because I divided by a negative number. Part of this, what I did by dividing by a negative number, is I changed this quantity into its opposite. So I need to also change the sign into its opposite. I need to change direction. X is solved for. It's a lone and positive on one side. And we're finished. X is greater than negative 9.